In today's episode, we're diving into the fascinating world of cement production in Namibia, a process that's shaping the future of the country's infrastructure. Stay tuned as we uncover the inner workings of Namibia's Ohorongo cement, one of the most advanced cement plants in Africa. Cement making in Namibia kicks off with a literal bang. It all begins with blasting the raw materials, primarily limestone, clay, and silica, from the earth, a dramatic start to a highly technical process. The process of cement production in Namibia starts with precision and power. 30 holes are drilled into the quarry, each carefully planned for maximum efficiency. Next, cartridges are inserted, followed by the filling of these holes with ammonium nitrate, a powerful explosive commonly used in mining operations. To trigger the blast, a detonator is added to each hole, setting the stage for an impressive controlled explosion. Each hole is then filled with gravel, and the area is cleared for detonation. At this quarry site in Namibia, there is a staggering supply of raw materials, enough to sustain cement production for the next 300 years. The most important raw materials for cement production include limestone, shale, and marl, all of which provide the essential ingredients like calcium and silica. However, to perfect the mixture and create high-quality cement, iron ore and gypsum are also required. Once extracted, the limestone, shale, and marl are loaded onto massive trucks, each capable of carrying 60 tons of material. These colossal trucks transport the raw materials to the crusher, where they are ground down to the consistency of rough gravel. The crusher at the plant is a powerful piece of machinery, capable of processing an impressive 600 tons of material per hour. After being crushed, the raw materials are transported to the mixing bed, where they are combined to create a homogeneous mixture. This step ensures that the limestone, shale, marl, and other essential ingredients, like iron ore, are evenly blended together. The goal is to achieve a perfectly consistent composition, which is crucial for producing high-quality cement. At this cement plant, roller mills are used instead of the traditional ball mills, offering a significant advantage in terms of energy efficiency. In fact, roller mills save approximately 30% of power consumption compared to their traditional counterparts. Cement production requires an immense amount of heat, especially during the clinker making process in the rotary kiln, where temperatures soar above 1,450 degrees Celsius. To meet these energy demands in a sustainable way, this plant uses an innovative solution, harvesting invader bush from the surrounding area as fuel. Once the raw mix from the mill is prepared, it undergoes a crucial transformation in the rotary kiln, where it is heated to an intense 1,450 degrees Celsius. This extreme heat causes the raw materials to undergo chemical changes, transforming them into clinker, the essential intermediate product in cement production. After the clinker exits the rotary kiln, it is rapidly cooled down to about 100 degrees Celsius in the cooler. This cooling process is crucial, as it helps preserve the quality and structural integrity of the clinker. After cooling, the clinker is finely ground and dosed with precise quantities of gypsum and, in some cases, high-grade limestone. The gypsum is crucial as it regulates the setting time of the cement, ensuring that it hardens at the right pace when mixed with water. Finally, the clinker, gypsum, and any added limestone are milled together in two cement mills. which grind the mixture into the fine powder we know as cement. Cement is so finely ground that just 1 kilogram of it contains about 300 billion grains. Once the batch of cement is produced, it undergoes rigorous testing to ensure that the chemical composition is correct. This is a critical step in quality control, as the right balance of ingredients, such as lime, silica, alumina, and iron oxide, determines the cement's strength, durability, and performance. After passing all quality control tests, the cement is ready for packaging. The plant's efficient packaging system can handle up to 6,800 bags per hour, ensuring a rapid and steady supply for various industries. These bags, typically weighing 50 kilograms each, are distributed to a wide range of sectors, including construction, infrastructure development, and road building. A single packaging line in this plant can fill enough cement bags in 1 hour to build a 5-story building. And there you have it. After all the precision, heat, and hard work, the cement is finally loaded onto trucks, ready to build the next marvels of the world. From towering skyscrapers to sprawling bridges and robust roadways, this cement will become the backbone of future infrastructure projects that push the boundaries of modern engineering. Let's keep the momentum going. Now that we've covered the cement-making process, let's turn our attention to another fundamental building material: bricks. Clay is first dumped at a designated area within the brick-making facility. From there, it is transported to the mill, where it undergoes a crushing process. This crushing is essential to break the clay down into finer particles, ensuring it can be easily mixed with water and other ingredients to form a smooth, workable material. After being crushed, the clay is passed through an extruder, which shapes it into long, continuous forms. The extruder forces the clay through a specially designed die, creating a smooth, uniform shape. Once the long extruded clay forms are produced, they are first cut into manageable lengths using automated cutting equipment. These sections are then further cut into individual blocks, forming the standard brick shapes. This precision cutting ensures that each brick has uniform dimensions. Modern cutting machines can produce up to 20,000 bricks per hour. Once the clay bricks have been cut into their final shape, they are carefully loaded into the furnace or kiln for firing. Temperatures reach between 900 degrees Celsius and 1,100 degrees Celsius, which transforms the soft clay into durable, solid bricks. After being fired and hardened in the kiln, the bricks are cooled and then stacked on pallets. This stacking process is done carefully to ensure that the bricks remain intact and undamaged. A single pallet can typically hold around 500 bricks. And there you have it. We've explored the fascinating journeys of both cement and clay brick production, two essential materials that form the backbone of our modern infrastructure. From the powerful blasting of raw materials and crushing them into fine particles for cement, to the precise extrusion and firing of clay to create durable bricks. Stay tuned for more insights into the materials that shape our everyday lives. Until next time.